All right, so yesterday you were introduced to the concepts of momentum, and momentum was mass times velocity, so P equals mv. And so let's just jump ahead until we get in touch with impulse. And we said that impulse was your quantity force times the time interval of which you are applying that force, okay? So the greater the impulse exerted on something, the greater will be the change in momentum. So the change in momentum is equal to your impulse. So this is how we get the equation Ft equals delta mv. And so as we keep jumping forward, we say that to increase the momentum of an object, we need to apply a greater force for as long as possible. So we were bringing this back to baseball and golf and saying, well, if we follow through with our swing, so if we're applying that force for as long as possible on the object, then we're going to have an increased momentum for that object, which is exactly what we want when we want to get like home runs or send it into the green. So now let's talk about decreasing momentum. So if you were in a car that was out of control and had to choose between hitting a haystack or a concrete wall, you obviously want to choose that haystack. And the reason that you want to choose the haystack is that if the change in momentum occurs over a longer period of time, then the force of impact is going to be small. So the momentum that you're entering the haystack and the wall is going to be the same. You still have that same mass that you're entering with the same amount of velocity. But what you can change is the amount of time that you're going to hit with that impact. So if you choose the haystack, you're actually increasing the time of which you are going to feel that impact, which is going to decrease the force that you feel yourself. And if the change in momentum occurs over a shorter period of time, like hitting that wall, then the force of impact is going to be large because the time of which you're going to feel that impact is very, very small, which is why, your car gets crumpled up and you get hurt. So always choose that haystack there because it always increases that period of impact time, which is going to decrease your force. But let's look. When hitting either the wall or the haystack and coming to a stop, the momentum is decreased by the same impulse. So the impulse for hitting the haystack or the wall is the exact same. We're not saying that the force is the same, we're not saying that the time is the same, but the product of the force and time is the exact same. So the same impulse does not mean the same amount of force or the same amount of time. It means that the same product of your force and time. So to keep the force small, we need to extend the time or extend that impact time. So when you extend the time, you reduce the force, which is why we have seat belts and padded dashboards and airbags and all that good stuff in our vehicles in order to increase that impact time, which decreases the force that we feel from that impact. Another example here is impulse on a boxer's jaw. All right, so the punch is coming in with a momentum, right, because it has a mass, it has a velocity. But the way that you can change the impact time is by either moving away or moving toward, right? If we moved away, we're going to feel less force on our face, which is always good. But when we move toward, then that impact time is going to be really, really short, so that we are going to feel the full effects of that force. So just like in that example right there. So again, when we move away or when the boxer moves away from with that punch, we increase that impact time, which decreases the force we feel. When we accidentally move towards the punch, maybe we took a wrong step or something like that, then the force is going to be huge. And that's just because of the shorter impact time. So when a dish falls, would the impulse be less if it lands on the carpet than if it lands on the hardwood floor? And the answer here is that the impulse is going to be the same for both. So just like with our haystack and wall example, the impulse was the exact same. So that product of your force and time is the same. But what's going to happen is that if your dish falls on the carpet, then the impact time is going to be increased because of the carpet. It has to settle down and all that stuff. So it's not going to be immediately impacted by that amount of force, like if it was on concrete or if it was on the hardwood floor. So again, the impulse would be the same with either surface, but the same momentum occurs the same momentum change occurs for each. If the force, that is less for the impulse on the carpet because of the greater time of momentum change. Okay, so again, that greater impact time for the carpet there. If a boxer is able to make contact time 5 times longer by riding with the punch, how much will the force of the punch impact be reduced? So since the time of impact increases 5 times, the force of impact will be reduced 5 times. And that's just going back to the equation. So if a boxer is like riding with that punch, so they increase their time by 5, then the force of impact is going to be decreased by that amount. All right, so let's talk about bouncing. So the impulse required to bring an object to a stop, then throw it back up again, is greater than the impulse required to merely bring the object to a stop. All right, so when you're thinking about bouncing, right, the ball is coming down, it's coming down for a brief second of stop, and then it's going back up again. And the impulse required to bring that object back up again is greater than it was to bring the object to a stop. So suppose you catch a falling pot with your hands, you provide an impulse to reduce that momentum to 0, and then if you throw the pot back upward again, you have to provide an additional impulse. And again, remember, impulse is that force times time.